We are back doing videos, flipping that classroom, keeping things moving. We are starting with exponents, and we talked about this a little bit today in class, the difference between monomial, binomials, and trinomials, and we reviewed exponents and what they mean and what you do with them. So let's remember that a monomial has one term, binomial has two terms. Trinomial has three terms. And a polynomial really is two or more terms. So a trinomial or anything higher than that, we just call a polynomial. Remember that a term can have a multiply or divide, but no addition. So this is a monomial. That's a monomial. That's a monomial. That's a monomial. So multiplying and dividing is okay, no adding and subtracting. Once you have adding and subtracting, it's a binomial. That's a binomial. So the whole adding and subtracting is what makes it a binomial, and a trinomial, of course, is then going to be three terms. Anything with three terms, as long as they're separated by your pluses and your minuses. So that's pretty straightforward. And then you also remember this whole thing, that this is your exponent, and this is your base. So when I say to the power of, we use the exponent. Okay, so if you're looking at 3, you could write 3 to the third power. Or as we do with our 3's, we say 3 cubed. I'm going to start sneezing. It's going to ruin the whole thing. Okay, we also write it as 3 times 3 times 3. So the base is the number we write down. The exponent is how many times. So this is how many, and this is what number. Okay, so 3 times 3 times 3 is 27. So 3 cubed is equal to 27. Okay, x to the fourth, same thing. The x is it's not a number, it's a letter. Okay, but the 4 tells us how many, let's try that again. How many we're writing. It is not equal to 4 times x. That is not correct. Okay, so it's 4 times x times x times x. Same way for number 5, if you want to put all this together, you would put the 3's together, the x's together, and the y together. So you'd have 3 times 3 is 9. There's 3 x's and a y. So because we don't know x and y, we leave it right like that, and that is a monomial. Okay, the product rule says that when you're multiplying the same variable, a monomial, you add the exponents. Which is kind of weird, but I think we talked about this. If I have q squared times 2 times q to the fourth, well, q squared is q, and then I have times 2 times q. Who thought q was a good idea? Woo. Okay, so what I end up with once I lay them all out like this is my 2, and then I have 1, 2, 3, 4, 5, 6 q's. So I have q to the 6th. And while you're practicing these, I write them all out like this so I can put them all together. And it helps when you're doing your dividing also. So we're going to talk about that later. So if I have negative 2u squared times 6u to the 6th, then I have negative 2 times u, and then I have my 6, and I have 1, 2, 3, 4, 5, 6 u's. So my negative 2 and my 6 get multiplied together. And then I'm going to count how many u's I have. 1, 2, 3, 4, 5, 6, 7, 8. And that means I have u to the 8th power. Again, a monomial. When you multiply two monomials, you get a monomial. Okay, 8 and 9 are scientific notation. And you probably, hopefully, remember scientific notation. You always have your decimal in the second spot, and your 10 tells you how many places you're moving the decimal. So this is the same as, if I move that decimal 3 places, I would have 3, 4, 8, 0, and 9, 8, 0, 0, 0 would be moving the decimal 4 places. So you can think about it that way, or you could think about multiplying 3.84 times 9.8. Handy dandy calculator. I don't think this one works. Oh, it does work. Okay. 3480 times. No, don't work. I have a whole bunch of calculators and no batteries. Yep, same with that one. Same with that one. Same with this one. Same batteries. Nobody has any batteries. Should have got my calculator out already. 3480 times 98000 equals 3410400. Ooh, what a pain. Don't I wish I hadn't started that. Okay, but if I take my decimal at the end and go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, I have 3.4 times 10 to the 8th. Another way to do that, because that's a mess, is to do your tens just like we were doing before. I have 10 to the 3rd and 10 to the 4th. That's going to make 10 to the 7th. And I do 3.48 times 9.8, and I get 34.104. I'm going to move the decimal one place over here, which is going to make that one more. And that's going to be 3.4 times 10 to the 8th. I have to learn to write smaller. So it's really the same thing as we were doing with the product rule. I added these together, and then I multiplied the 3.48 times the 9.8. And I got 3.4 times 10 to the 8th. So when you look at number 9, we're going to have 0.8 times 1.28. And then that's going to be times 10 to the 4th, times 10 to the 6th, 10 times 10 times 10 times 10 times 10, blah, 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 blah. A lot of 10s. So if I do 1.28 times 0.8, I get 1.024. And I have 10 to the 4th and 10 to the 6th, which makes 10 to the 10ths. So it does not like me doing decimals. Okay, so just like when you did your exponents here and added them together, you do these exponents here and you add them together because the bases are the same. As long as the bases are the same, you add the exponents. So add exponents when multiplying, as long as bases are the same. I could not do, well, I could, but we're not going to talk about that right now. Never mind. Okay, power rule. When you have a monomial to the power of something, you multiply. So when you have exponents to the exponent, exponents to a power, you multiply. And here's what it looks like. If I have 2a cubed to the fourth power, what I'm writing 4 times is the base, which is 2a to the third power. So I have 2a cubed times 2a cubed times 2a cubed times 2a cubed. My base is 2a cubed, and I write it 4 times. So now I can look at it and go, oh, well, I have a cubed, a cubed, a cubed, a cubed. 2 times 2 is 4, times 2 is 8, times 2 is 16. And I have 3, 6, 9, 12 a's. So basically, I did 2 to the fourth power, which is 2 times 2 times 2 times 2, a to the third power to the fourth power, which means I have a cubed 4 times, which is a to the 12th. Okay, so number 11, here's my base. My 3 is not part of my base. So my 3 just stays out here by itself. But I'm going to write 4y to the 6th. How many times? 4. Very good. That's a 6, and that's a 6. Okay, so I have 4 times 4 times 4 times 4. That's 16. That's 64. That's 256. Times 3 is 768. And then I have 6, 12, 18, 24 y's. I hate it when I start doing that and then I start messing it up. 768 y to the 24th. Okay. So the product of the power is the same thing we were just doing, except we have multiple variables, but we're still doing the same thing. So the product of the power means, whoa, okay, that we do our, basically what we're doing is we're taking our exponent and we're distributing, if you can want to think of it that way. So you distribute the exponent to everything inside, which is kind of what we were just doing, but this is a little bit more of a shortcut when I finally get down to it. But basically, here's my base. I'm going to write it how many times? 3 times. So that when I'm done, I have 2/3 times 2/3 times 2/3. So let's just think of 2 times 2 times 2 on top is 8. And 3 times 3 times 3 on the bottom is 27. And then my x's, I have 2, 4, 6 x's and 3, 6, 9 y's. And so my answer would be that. So basically, if you look back at the problem, I did 2 over 3 to the third power. I did x squared to the third power. And I did y cubed to the third power. So you can either think about it this way, you could either work it out like that, and it comes out the same. So number 13, let's do it both ways. Well, actually, we could do this one on our head, but I'm going to have This is my base. And I'm going to write it 2 times. And if I wanted to really write it all out, I could do x, x, y, 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 z, right? And then I could do it again because I have the same thing again. At some point it gets tiring of doing this and you're going to want to do your shortcut, which is just 2 times 2 for the x, 2 times 4 for the y, and 2 times 6 for the z, which here's my 12 z's, here's my 8 y's, here's my 4 x's, so that this is my answer. But I can spend a lot of time writing it all out. If I'll remember my rule, I can just multiply my exponents times each one, and I'll have my answer. So don't forget to always do it the easy way. All right, so let's do our formula for triangle. And we have A equals 1/2 base times height. So here's my base, here's my height. I'm going to multiply them together. So I have 1/2 times 5c cubed d and 8c squared d to the 4th. So I'm going to have a monomial because all these are being multiplied together. So I'm going to multiply 5 times 8, which is 40, and then I'm going to take 1/2, which is 20. I have 3 c's and 2 more c's, which is 5 c's. And I have 1 d and 4 more d's, which makes 5 d's. So don't forget, if it's just the letter, it has a power of 1. Okay, so if I'm doing the area of a square, I multiply my sides. So basically I have 3x squared, y squared, and I square it. So I'm squaring everything inside. So I have 3 squared times x squared squared and y squared squared. So my 3 squared is 9. Cross off c and d. My x squared is 4 and my y squared is 4. So my answer is A. Okay, a prism, still monomials. Okay, so my prism, when I do volume, I multiply the 3 measurements together. So I'm going to separate them. I'm going to have 4 times 7.1 times 2.3. And then I'm going to have 10 to the 4th, 10 squared, and 10 to the 3rd. So 4 times 7.1, I'm going to get out my calculator. 4 times 7.1 times 2.3. 65.32 times 10. And I have 4, 5, 6, 7, 8, 9. 10 to the 9th. This is not standard scientific notation. So I'm going to move my decimal one place over to the left, so it's standard notation, which means I add 1 more to the 10th. So it's going to be 6.532 times 10 to the 10th. That would be my answer when I'm done. And we can talk about that more tomorrow. Scientific notation you've touched on before, but kind of just got thrown in there. So we'll go over it a little bit tomorrow before we do our practice. But here's my video. It's staying pretty short, I hope. And we'll go back up here so we can go, yay, confetti, Happy New Year. All right, see you tomorrow.